Consumer surplus. So what it is our difference between what a consumer would expect to pay and what they actually pay. So it's basically quantifying their savings. And I think of it as how happy they are. So the more they've saved, the happier they are. So let's look at this with Desmos, this graph, and then we'll come back and mark it up. So what this graph does is it tells us the number of units and the price they were sold at. So what this is saying is for 9.7 units, you'd have to charge 24.628. And so as you can see, as the price goes down, more units are being sold. This is how our demand equation works. So let me see if I can get this right on 30. So 30 units, $8.93. And if we go all the way to 50, you can see that for 50 units, they charge $3.28. So as they decrease the price, more units are sold. And this is a normal idea. I'd like to think of a shoe store. You walk into a shoe store because you need shoes. And they're charging $100 for the pair you want. Well, you need them, so you buy one pair. Now, what if they were selling that same shoe for $20? Well, at $20, you're going to buy a lot more than one pair. So if you decrease the price, you increase the sales. So this is what we consider as savings. So if you look at our rectangle here, so for 1 unit, right, this person would have said, I would have paid $38, but the price is $3.28. So that means the difference between $38 and $3, so $38.05 and $3.28, that's the savings for that one person. Only one person would have paid $38. Now, two people would have paid $36.19, but they only had to pay $3.28 because that is the price that we're selling it for. So what we're looking for is we want to add up all of these savings. So that one person, well, that's his savings. And then for two people, that's our savings. So you can think of this little rectangle here as the savings for each one in between. And we're going to take and add them all up. So what we need to do is, again, find the area of that rectangle. And this function should look very, very familiar to you. It's just the area in between the curve. So if we mark this one rectangle up, it's got a width of dx and a height of our y, and it's top minus bottom. So our top here is our p of x, which is our 40 e to the negative 0.05x. It's our demand equation. That's what that is. And right here we have x equals 50. And so what that's going to do is give us some y values. So if we plug in 50, we'll plug that in our calculator now. It's going to give us that y equals equation that we want here. See, on each of these, it's top function minus bottom. So it's just going to be our integral from a to b of top minus bottom. And I like to put start and finish. So in this equation, if you want a formula for this, this is the integral from a to b of our p of x minus our price that we're going to be paying. So this is the price we're paying. So 50 units were sold. So that's the price that needed to be charged for 50 units to be sold. So if we take that now and we plug it in our calculator, you know what, that looks horrible. Let's write that again. Something that looks a lot nicer. You know, it's really hard for me to do it from this distance, so I've got to zoom in to make it look nicer. So integral from start to finish of top minus bottom. So it's just the area between the curves. That's all it is. And so this is going to be the integral from a to b, and then our demand equation, p of x, minus our price, dx. So that's what we're going to be doing. You have some demand equation. If you plug in the x equals 50, it will tell us the price. So we really want to be using a calculator when we do this to get nice, clean numbers. I mean, obviously you can plug in 50 and use this exact value here to find the exact value, but we're just going to be using the calculator for the whole thing. So we're going to take and plug this function in, our demand equation, 40 second e to negative 0.05x. Perfect. And then we're going to go to our window. And now we're going from 0 to 50 units, so that's all we need to see. I like to go a little bit farther, just because. And then you hit zoom 0, which is fit, And you see if that's our graph. Now what it's going to do is only graph to that lowest point there. So we have to go back to our window and change our y-min back to 0 so that we get a clearer picture. So now when I hit graph, you can see everything is good. So now if I were to plug in, say, 1, it tells me that the price would be $38.05 to sell 1 unit. And if I plug in 2, it tells me it has to be 36. So we can see the price is going down, more units are sold. And we have to add up all of these to get our perceived savings. So now we go trace 50. That is the actual price we're going to pay. So $3.28. That is what is actually going to be charged. So we're saying for 50 units, we would charge $3.28, or for $3.28, we would sell 50 units. So now we plug that in. Our integral is from 0 to 50. You can see where that x comes in. And then it's 40 e to the negative 0.05x, our demand equation. That's our top minus our bottom. Why did I put equal? I don't know. And then minus our price, $3.28. That would be our bottom equation. So this is y equals 3.28. So by plugging in the x into our demand equation, it tells us what our y equals is. It tells us what the bottom function is. So now all we have to do is plug that in our calculator, and we'll get our answer. So from 0 to 50 of top minus bottom, that's what we have. We get 570.33. Now you always want to go back and make sure we have our units correct. So it says price P is in dollars, X is in units. So if we do 50 units, the price would be $3.28. So if they charge $3.28, that's our perceived savings. So it's all of these savings at 1, 2, 3, 4, 1.5, 2.5, all of them. All of our perceived savings added up. And so that is our consumer surplus. Now, you can also put that price in as well down here. So if we put the 3.28 in and hit graph, it's another way to verify that it's 50. So if you go second calc, intersect, enter, 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 you can see there's our 50 units. It's a little off because we rounded this, so that rounds off as well. And so what we're doing again is just finding the area in between both of these. And just to give you an idea of what's going on, we can use the calculator as well by doing number 7, which is our integral. So we're on the blue. So we're going to go from 0, that's our left, to our upper limit of 50. And it will shade it and give us a number. So 734.32. So $734.33. Take away, and then when I will do the bottom one. So we do the same thing, number 7. Now this is not going to be exact. And we want to make sure we select the red. And then the left would be 0, and then 50 for our upper, and it shades it in 164. And so if you subtract those two, you can actually see that right there in the blue is our consumer surplus. So 734.33 minus 164. And there's our 570.33. Pretty nice, right? So that's all we're doing here is adding them all up, either both with separate integrals or one straight integral, which I recommend. But it's just the top minus bottom. That's all it is.